The Optimus 3 design, as I mentioned earlier, is, I think, finally the right design.
Gone are the bulky joints and plain plastic shells. The new version features a sleek black and white exterior, a well-proportioned body, and a gait that closely resembles a human's. With this design, Tesla aims to produce over 10,000 Optimus robots in the initial phase. So, what specific design changes has Tesla made to Bot Gen V3? What changes are made to the robot's outer shell? The latest design of Optimus Gen 3 marks a strategic turning point in the commercialization process of Tesla's humanoid robot. Instead of continuing with the rough, mechanical look of earlier versions, Tesla has adopted a completely different design language: seamless, minimalist, and reminiscent of a high-end tech product. This is not merely a change in appearance, but a declaration that Tesla's robot is now ready to enter human life, no longer confined to factories or laboratories. The design element, seemingly secondary, is actually a crucial foundation that helps Optimus Gen 3 stand apart from earlier versions and competing robots on the market. First and foremost, the most noticeable change lies in the exterior. Bumblebee, the first robot Tesla introduced in September 2022, resembled a prototype model, with exposed mechanical joints, visible wiring, a bulky metal frame, and disproportionate body ratios. Gen 2 made progress in mechanics and movement, but still retained an industrial-focused design. Joints were still visible, the head looked quite crude, and the outer shell merely served as basic coverage. By Gen 3, the entire torso, arms, and legs are covered in a smooth, white composite shell that runs seamlessly from neck to foot, with no visible mechanical components. The robot's head is completely black, made of a glossy, mirror-like material, with no eyes, nose, or mouth, creating a futuristic appearance and completely avoiding the uncanny valley effect that often occurs when robots try to mimic human faces. This design language makes Optimus look more like a modern electronic device than a machine. This is a critical factor, because in the process of introducing robots into human environments, minimizing the mechanical feel is essential for user acceptance. Many studies have shown that consumers tend to react negatively to robots that look human, but are not quite convincing, an effect known as the uncanny valley. Tesla has solved this problem by not making the robot resemble a human, but instead opting for an abstract design: glossy black head, smooth white body, graceful posture, like a fusion between humanity and technology. This is why many people, upon seeing Optimus Gen 3 for the first time, tend to associate it more with an Apple product than with an industrial machine. A comparison with other market competitors shows that Tesla's approach is completely different. Boston Dynamics' Atlas robot has a bulky appearance, exposed metal frames, and clearly visible motors and hydraulic cylinders. Although its acrobatic abilities are impressive, Atlas looks unfriendly and unsuited for close interactions with humans in environments like homes or restaurants. On the other hand, Figure 01 from the startup Figure AI, though also pursuing a minimalist style, still has several aspects that fall short of Optimus Gen 3's refinement. Its arm, neck, and leg frames remain somewhat bulky. Body proportions are not yet fully harmonious, and the outer shell lacks the sleek finish needed. In contrast, Optimus 5.3 appears like a final product, ready for mass production and everyday use. Beyond aesthetics, the seamless design of Optimus serves the goal of mass production at low cost. Elon Musk has repeatedly affirmed the goal of producing 10 to 20 million Tesla bots annually, with a unit price under $20,000, a shocking figure compared to other humanoid robots, which typically cost $80,000 or more. To achieve that, Tesla had to redesign the robot's entire structure to suit automated assembly lines. The use of a seamless composite shell reduces the number of surface components, cuts down on molding costs, and eliminates the need for manual assembly procedures. Instead of technicians attaching each joint, like in traditional robot manufacturing, Tesla can use industrial robots to pick up arm and leg modules and quickly attach them to Optimus's torso. These modules are also designed like electronic devices, quick to detach and install, without needing to dismantle the entire frame. This is something competitors haven't achieved, as they're still in the prototype phase, relying on manual assembly and unable to optimize the manufacturing process. Another advantage of the seamless design is the significant reduction in robot weight, which improves efficiency and safety. Optimus Gen 3 weighs only 56 kilograms, while Figure 01 weighs about 65 kilograms, and Atlas up to 89 kilograms. This difference not only helps Optimus save energy, only around 100 watts when idle and approximately 500 watts while walking, equivalent to an industrial fan, but also reduces risk when operating near users. A robot under 60 kilograms can be better controlled, stop more quickly in emergencies, and is less dangerous in real-life environments, especially where there are children or the elderly. The lower weight also allows Tesla to use smaller motors, lighter batteries, and reduces production costs, a virtuous cycle of optimization that offers a major competitive edge. In addition, the composite material enables the robot to withstand diverse usage conditions: dust resistance, scratch resistance, impact durability, and easy cleaning. This allows Optimus to function in various settings such as homes, restaurants, hospitals, hotels, and even light outdoor environments. Robots with exposed metal shells usually need to avoid grease, moisture, and require detailed cleaning, while Optimus can be wiped down like household appliances. Finally, the new design adds brand value to Optimus, a rare achievement among industrial robots. Tesla is not just selling a robot but promoting a technological icon, similar to how the iPhone once reshaped perceptions of what a phone could be. The image of Optimus standing on stage next to Elon Musk is not just a product launch, but a media strategy, making people aspire to own a robot as a piece of cutting-edge technology, not just as a mechanical tool. When you design a robot beautiful enough to display in your living room, you're not just solving an engineering problem, you're opening the door to the consumer market. Why did Tesla decide to completely redesign Optimus Gen 3? This is the first time Tesla has clearly demonstrated a first principles design philosophy, meaning not just making incremental adjustments from previous versions, but starting from the ground up, similar to how they completely reimagined the electric car when launching the first Model S. One of the key reasons Tesla had to redesign was the production scalability limitations of Optimus Gen 2. The previous design, while impressive in overall form, still relied heavily on manual assembly, with external casing components not yet standardized for robotic mass production. The joints used traditional welded and mounted parts, making full automation difficult. In contrast, Optimus Gen 3 features a monocoque exterior structure, which dramatically simplifies the manufacturing process. Elon Musk even revealed that this new version was designed for production of millions, not for display in a lab. Transitioning from a prototype robot to a truly commercial product requires not only technological advancement, but a complete structural redesign to ensure low cost and high scalability, something Gen 2 could not deliver. The second driving factor behind this redesign is weight and energy efficiency. Optimus Gen 3 is significantly lighter, weighing only around 110 pounds compared to the previous version's nearly 160 pounds. Cutting over 50 pounds not only allows the robot to move more nimbly, but also reduces material usage, lowers battery and mechanical wear costs. To achieve this, Tesla had to restructure the entire chassis, utilizing a combination of extruded aluminum, carbon fiber, and composite materials in areas like the chest and calves to maintain strength while minimizing weight. With the old design, reaching this weight level would have been nearly impossible without compromising structural integrity. This shows Tesla has fundamentally altered both mechanical logic and materials to pursue holistic optimization, not just for performance but also for large-scale production. Another key improvement is the optimization of maintenance and disassembly. Gen 3 is designed in a modular fashion, where parts such as arms, legs, face, battery, and sensors can be quickly detached using a few locking joints, similar to swapping a battery in a Tesla car. This allows for easy repairs, part replacement, and software upgrades, critical factors when manufacturing hundreds of thousands of units. In contrast, Optimus Gen 2 had a more rigid structure with complex assembly, making part replacement time-consuming and not well-suited for mass maintenance. Elon Musk once emphasized that a good product is one that's easy to manufacture, easy to maintain, and easy to replace parts.